This video is intended to demonstrate how to use an existing VI as a sub-VI, take the data from an existing file, process them, and then rewrite them to a spreadsheet file, something that happens quite frequently in use. So let's start with an existing VI. As before, we will click and create us a new VI that we're going to use. Again, we'll go to the block diagram, and to get an existing VI, we will click here. Often you have to scroll down to the bottom or look around until you find the thing that says select a VI. So if we select a VI, one that might be useful is called read in file, and we will place that in our block diagram here. As before, we can go around and it will tell you there's a matrix, column 1, column 2, column 3, column 4, and file that was read. This gives you the name of the file that was read. If we're curious, we can actually double click the icon and up will pop the front panel, and we can see here the icon that's been created and how those connect to the various controls and indicators that are here. We could also Control E to look at the block diagram, and that block diagram looks fairly useful. Okay, so we'll just close that because we don't need it to look at anything in it at the moment. But this VI can be used as a sub-VI to accomplish what we want. Since it already gives us columns 1, 2, 3, and 4, we don't need to split things up, but because it also gives us the matrix, if we wanted, we could do the index array sort of thing that we've done before. Okay, so now this one, column 1 might be time in seconds, for example, and we need the time in minutes, so we want to divide it by 60. There are multiple ways to do things in LabVIEW. For this particular case, we're just going to use the divide sub-VI, and that is in the numeric indicator. Here we have add, subtract, multiply, and divide. These are all polymorphic object-oriented objects, so it will make sense out of whatever you want. You can divide two scalars, you can divide two vectors and other things of that nature, and it will complain if you try to do things that aren't going to work very well. But let's take our divide here, and we will click it there. I'm going to take and connect that to column 1. So I've got column 1, and I want to divide that by 60, so I will right-click, create a constant. That didn't work very well. It created an array constant. So what I'm going to do is something different. We'll get rid of that. We'll undo that create, and what we're going to do is just plain click on here, numeric, and we will go to a constant. We will make our own constant and type 60.0 just for fun in there, assuming we can double click on it, 60.0, and then we will connect that here, and now divide all of the values in the array by the scalar constant 60. Okay, the other things that we might want to do are perform some other functions. Let's take the sign of the second column. So to find those again, I could go up here and type search. I'll go ahead and type that in, and it will help me find sign, trigonometric functions, and if I click there, it shows me the trigonometric functions. There's the sign. I will go ahead and drag that one out. And so if I want the sign of column 2, I can just connect column 2. Now I've got the sign of it. Cosine, I may want that, so I will go to my mathematical functions, since I know where they are, elementary functions, trigonometric functions. Try this again. Mathematics, elementary, trigonometric, and there's my cosine. And I'll take the cosine of that column, and the final one I might want to square it. So what I'm going to do is, again, click here. I could hunt for the squared thing, but I know under numeric, happened to notice it when I was looking around. There's a nice one here that says square. So I will take that and I will square the output of that column there. Okay, so now we probably want to take and plot these columns 2, 3, and 4 as a function of column 1. And if we recall from our previous example, we'll have to bundle some things together. But if we don't recall for sure, what we will do is go to our front panel, and we will again put on our XY graph. And let's see, what's a good name for it? Plot. That's not a very good name. You can come up with a much better name than that. But this time, because I think the time is now in minutes, I'm going to put parentheses minutes in there so that my professor doesn't get mad at me for having something without units on it. Okay, I'm going to stretch this so it's going to be a bit bigger, and I'm going to open this up just a touch because there's a little trick that I want to do in a minute. And I'm going to move this over here, and I know I'm going to have 3 columns, so I'm going to stretch that down. I will call this column 2. This one I'll call column 3. This one I'll call column 4. Now, at the moment, I could actually run this and read in a file. The only problem is nothing would happen. And why would nothing happen? There's no connection between the plot, which is sitting here, and these various process columns. So I'll go ahead and show that nothing terribly useful happens. Again, it comes up, and we will read in our test file, and it did exactly what we told it. So it read those in, it calculated all those things, and then did nothing with them. So if we want to put together bundles as we did before, we will go to our cluster class invariant and create bundles there, and I need 3 of them. So I'm going to put one down, control click and drag this to create a second one, and then finally a third one like that. And I will put them a little closer to where they're actually being used, which is those 3 locations there. So now I'm going to take and put my X in there, and just for fun, I'm going to clean up this wire. I right click on it and choose clean up wire, and it makes it look a little nicer. This way I can easily have it be the X for these 2 bundles as well. Then my Y's are going to be easy to do. I'll take the sine of column 2, the cosine of column 3, and column 4 squared. But now, how am I going to put those 3 bundles into the plot? Again, I will go to my context help and go over there. And if you notice, it says what you do is you take the individual plots and you put them together as an array. So you make an array of bundles, and each of your bundles is a bundle of 2 arrays. So you have an array of bundles of arrays. Interesting. But you do whatever LabVIEW tells you in the context help, and life will be good. Okay, so clear up some screen real estate. Right click. I can look under my arrays, and there's something called build array. I need more than one, so I will click and drag down. I need 3 of them, and I think I want that there. So what I'm going to do is I will put the first bundle in there, the second bundle there, third bundle in there, and now I have to remember to connect my bundle to my plot, and everything's happy. There are no funny X's, and my little arrow's happy, so life is good. Perhaps I should save this program as well. Control S, it's VI as well. Control S works reasonably well. And plot stuff is not a real clever name, but we will call it plot stuff for the moment. Okay, and clicking on OK, we've got that saved. So let's run it, because we can run it just about any time we want and see what we get. If we read in our test file, why, looky there. We have things that look very nice. And as before, we could change our colors and plot styles or anything else. Let's make the first one a nice crazy yellow. So we've got yellow, green, and red. And just for fun, column 4, let's make it a bunch of individual plots. And there you can have the individual plots. You can do lollipop diagrams or all sorts of cool things depending on what you want there. Okay, so that was useful. But perhaps what we want to actually do is write this out as a file. And so what we would want to do then is make an array of the 4 processed arrays that we had. And so again, we can go get our build array tool, or we could drag our other one, but no reason not to just drag one. They're pretty close. And then we will connect our 4 arrays together. There's the column 1 processed into minutes. There's the sine of column 2, cosine of column 3, and the square of column 4. This is starting to look kind of ugly, so I think at this point I might want to spread things out a little bit just so I can see them. You could also do the Command U, but that might make things less pretty than you'd like. And that wire in particular I want to clean up, and maybe this one as well. Okay, so now it looks much better. I've put the 4 of them together, and now since I want to write it into a tab delimited text file, I'll do the opposite of what I did before, and I will go to my file IO. There's one here called write spreadsheet, and I will put it there. It looks like I can put in 2D data, 1D data. I appear to have 2D data, so I will put them in like that. And now there are some other things going on here. I need to put the format. The default format is the %sign .3f. So you put 3 decimals after the 3 digits after the decimal point. That one is fine if you need to save lots of space, but these days computers are so fast, memories are so big, that we will just have it write out all of the precision that it's got. So we will create a constant, and we will change the .3f to a G, and now it will write out tab delimited with all of the things in between. Notice if we didn't like tabs, we could look around and see if we can find some character. Here the default is to put a tab between them, but if we wanted comma delimited, we could create a constant here and put commas, or we could put asterisks or whatever crazy thing we wanted for delimiting our file. Okay, one thing, we might want to know the name of the file that we wrote. So I am going to create an indicator here, and I'll call this file that was written. And so that way, again, go to my block diagram. It looks like it put it down there a little bit. I can probably stretch this out because that name does not look terribly long as it is. And so now if I stretch that out, we can actually do this. Now there's one thing I'm not going to show you that happens, but if you run it just as it is, instead of having the rows and columns how you would like, which is 4 columns each with a whole bunch of rows, this one would write 4 rows each with a whole bunch of columns. I recommend that you test it out yourself and see what the file looks like. But because we don't want that, we will come down here to the thing that says transpose, and we want to transpose it before we write it out. So again, we will right click and we will create a constant. This is a Boolean constant. You can tell by the little dashed green line there. And we will toggle it. See the F, we will change that to a T. Now it will transpose it before it writes it. Might as well save it as long as we're here. And now if we run the program, the first one says choose file to read, so we'll read in the test file. Then it tells us choose a file to write, and write out file, and probably I want a .txt at the end so that Windows is happy and knows what this is just a text file. And then if I click on that, it has written the file out. And if we went and looked at the file, we could see that it's tab delimited text. It will take a minute to hunt through the hierarchy to find the file, but that's what you get there. So that's how you process data and then write them out to a file. You could then open that easily in MATLAB, or you could open it in Excel and process them further.